Hey guys, it's me Mohammed from the Soft Learners, and in this video we are going to study different distributions of G protein coupled receptors in different systems of the body. For example, as we know, cholinergic receptors are of two types: nicotinic and muscarinic. The nicotinic receptors are basically the ion channels, while the muscarinic receptors are basically G protein coupled receptors. They are GPCRs. So the nicotinic receptors are ion channel, while muscarinic receptors are G protein coupled receptors. And the other system present in our body, like adrenergic system. The adrenergic receptors are divided into alpha 1, alpha 2, beta 1, beta 2, beta 3. All of them are G protein coupled receptors. The alpha 1 or belong to the family GQ, alpha 2 belong to the family GI, and beta 1, beta 2 and beta 3, they belong to the family GS. So cholinergic system consists of cholinergic receptors which contain nicotinic receptors and muscarinic receptors. The nicotinic receptors are basically ion channels and muscarinic receptors are G protein coupled receptors. So the adrenergic system consists of alpha 1, alpha 2, beta 1, beta 2, beta 3. All of them are G protein coupled receptors, in which alpha 1 are GQ, alpha 2 are GI, G inhibitory, while beta 1, beta 2 and beta 3 are G stimulatory. Now, as we know, another type of receptors, dopaminergic receptors. Now, dopaminergic receptors are basically of two types, D1 and D2. D1 are basically G stimulatory, while D2 are G inhibitory. Now, as we know, GQ work through IP3 and DAG pathway. So they basically increase calcium level in the cell. G inhibitory, as we have studied, decrease cyclic AMP, while G stimulatory increase cyclic AMP. So alpha 1 increases calcium level, alpha 2 decreases cyclic AMP, and beta 1, beta 2 and beta 3 increases cyclic AMP into the cell. Same here, D1 increases cyclic AMP, while D2 decreases cyclic AMP into the cell. Now we come to another class of receptors called as purinergic receptors. Purinergic receptors are basically of two types, type A and type B. They both are G protein coupled receptors. Type A are sensitive to adenosine, while type B are sensitive to ATP. Now there is another class of receptor present in our body called as the very important indeed class known as GABAergic receptors, known as gamma aminobutyric acid receptors. Gamma aminobutyric acid receptors. They are very important receptors present throughout in the CNS. They basically have inhibitory effect. GABA receptors are of two types. GABA A and GABA B. GABA A are basically ion channels, ligand-gated ion channels, while GABA B are G protein coupled receptors. They both act through the inhibition of the next neuron present in them, so they both have inhibitory effect. Now the very next class is thyroid stimulating hormone. They act on receptors which are also G protein coupled receptors, or thyroid gland. They contain receptors for thyroid stimulating hormone. These receptors are also G protein coupled receptors. Now, or luteinizing hormone, it also works on G protein coupled receptors, same as adrenocorticotrophic hormone. It is also G protein coupled receptors. Now, rhodopsin present in the eye, they also act by G protein coupled receptors. The neuropeptides present in our body, all of them are G protein coupled receptors. The examples of the neuropeptides, for example, first example is vasopressin. Vasopressin receptors are of two types, V1 and V2. V1 are present on blood vessels, while V2 present on collecting tubules. So whenever V1 are activated, they cause constriction of vascular system, while V2 cause reabsorption of water. So the vasopressin receptors are basically of two types, V1 and V2. V1 are present on blood vessels, they cause constriction of blood vessels when activated, while V2 are present on the collecting tubules present in the nephrons of the kidneys, they cause reabsorption of water. If V2 receptors are not performing their functions, then there is a disease called as nephrogenic diabetes insipidus. Nephrogenic diabetes insipidus, where excessive water will be lost through urine. Now the next class of neuropeptides is ADH hormone. They are also G protein coupled receptors. Different opiates present in our body, they are also G protein coupled receptors. And oxytocin, it also works through G protein coupled receptors. So basically these are the systems or the ligands and hormones and the different parts of the body which have G protein coupled receptors and which act by G protein coupled receptors. This is all in this video, and in the next video we are going to start second major class of receptors called as ligand gated ion channels. Thanks for the watching. Please subscribe our channel.